Imagine there's no heaven. It's easy if you try. No hell below us, above us only sky. Imagine all the people living for today. Imagine there's no countries. It's easy if you do. Nothing to kill or die for, and no religion too. Imagine all the people living all in peace. You may say I'm a dreamer, but I'm not the only one. I hope someday you can join us, and the world will live as one. Hello folks, welcome to the Plain Mundane Show. I'm Alex Aquarius. Today we're going to talk about what's above us. The Van Allen radiation belts. Alright, now let's look at Van Allen radiation belts. Here we go. Let's switch the screens here. Alright, these are the Van Allen radiation belts. There's a lot of discussion right now on the internet as to what they are, where they are, if astronauts ever went through them or not. So what I'm going to show you here, this is your basic shape of the Van Allen radiation belts. You've got the inner belt, which is 290 miles up to the first layer. This is positive protons here. The outer belt is negative electrons. Okay. From this inner belt starts at about 290 miles up. The final edge of the outer belt is 36,250 miles up. So when you go from roughly 300 miles to 36,000 miles, that whole period, there is a safety zone in the middle, they say. But you have to go through the inner belt and the outer belt. Okay? Now, let's read from some Wikipedia. This is how you do research, folks. I'm just looking at some of the definitions that you can find. You know, I've got my other laptop here, my Chromebook, and I just look up, whatever's on Wikipedia as the Van Allen radiation belt. So we're just going to read from this a little bit. Here's the introduction for what it is, okay? A radiation belt is a zone of energetic charged particles, most of which originate from a solar wind that is captured by and held around a planet by the planet's magnetic field. The Earth has two such belts, and sometimes others may be temporarily created. The discovery of the belts is credited to James Van Allen, and as a result, the Earth's belts are known as the Van Allen belts. Earth's two main belts extend from an altitude of about 464 kilometers to 57,936 kilometers. Divide that by 1.6. That's your kilometer to mile conversion, 1.6. That's 290 miles to 36,250 miles. Above the surface, in which region radiation levels vary, most of the particles that form the belts are thought to come from solar wind and other particles by cosmic rays. By trapping the solar wind, the magnetic field deflects those energetic particles and protects the Earth's atmosphere from destruction. The belts are located in the inner region of the Earth's magnetosphere. The belts trap energetic electrons and protons. Other nuclei, such as alpha particles, are less prevalent. The belts endanger satellites, which must have their sensitive components protected with adequate shielding if they spend significant time in that zone. In 2013, NASA reported that the Van Allen probes had discovered a transient third radiation belt, which was observed for 4 weeks until it was destroyed by a powerful interplanetary shockwave from the sun. It must have been temporary. Good thing it's not there now. Let's see. Discovery. I'm not going to get into that. You know who discovered. His name is Van Allen. James Van Allen. Okay. Research. The Van Allen probes. Let me close these messages here. Okay. The Van Allen probe's mission aims at understanding, to the point of predictability, how populations of relativistic electrons and ions in space form or change in response to changes in solar activity and the solar wind. NASA Institute for Advanced Concepts funded studies have proposed magnetic scoops to collect antimatter that naturally occurs in the Van Allen belts of Earth, although only about 10 micrograms of antiprotons are estimated to exist in the entire belt. Who cares? Let's see. Let's go back down to the inner belt. Inner belt extends typically from an altitude of 0.2 to 2 Earth radii. That's 1/5 of the Earth's diameter to 1 diameter. 2 radii is 1 diameter. Okay, so that's the distance of the outer belt, okay? Earth, in certain cases, when solar activity is stronger or in geographical areas such as the South Atlantic anomaly, the inner boundary may decline to roughly 200 kilometers. That's only like 125 miles up above your head. Those inner protons of that inner belt. Okay, the inner belt contains high concentrations of electrons in the range of hundreds of kiloelectron volts and energetic protons with energies exceeding 100 mega electron volts. Trapped, that reminds me of CERN, which is right now operating at, that's what they're doing, teravolts, which is way higher than that. Teravolts. Mega teravolts. TeV. I'm looking at MeV here. TeV is way higher. Okay. Let's go to outer belt. The outer belt consists mainly of high energy, 0.1 to 10 mega electron volts. That's MeV. Electrons trapped by the Earth's magnetosphere. It is more variable than the inner belt, as it is more easily influenced by the solar activity. It is almost toroidal in shape, beginning at an altitude of 3 and extending to 10 Earth radii. Okay, let's look at some pictures that I found just looking up Google Pics. Here's a picture of the belts. Let me change my screen here. Look at that. Excuse me. If you're looking at the round Earth ball heliocentric model, it looks like a big donut where the Earth is the ball, the donut hole in the middle. And look at that. You see those lines? The radiation belts come out of the poles. Okay, we live in the climatic zones, which are between the latitudes from mostly around north and south of the 33rd parallels, north and south, and the equator, which is right in the middle of that band. And orbits go with the latitude lines. We don't orbit the Earth longitudinally. In fact, that's one of the proofs why the Earth is flat, because you don't see anybody orbiting the Earth longitudinally. They're always orbiting near it this way, which would mean the entire time they're underneath the belts. Now, there's a lot of people right now, because of Research Flat Earth and this billboard that went up in Philadelphia on the Schuylkill Expressway this week. They're researching flat Earth, and one of the first questions that comes up is, what are the Van Allen radiation belts, and did we go through them, and what difference does that make if the Earth is round or flat? So look at this, folks. I'm getting people commenting on my stuff, and I'm on other pages arguing with me, telling me science is science, dude, and that's why you're retarded, and flat tards are retarded because science is science. And they say that the astronauts from the Apollo missions never had to go through these belts because they went through a different trajectory. Well, if you're taking off from Florida and you're going this way around the Earth, you're right under that belt, right under this apex curve here, okay, in the center. And that's only 290 miles up. You know, low Earth orbit is 250 miles up, about right there. No wonder we can only get to low Earth orbit. Look up ODD Reality's YouTube channel, his video. 5 times the government has told us that we cannot leave low Earth orbit. This is why. You can't go beyond this 290-mile limit right there, which they say dips down to as low as 125 miles. You know, some of the astronauts have said, well, we just went through it because we didn't know it was there. Oh, so it didn't hurt you because you weren't aware of it. That makes a lot of sense, right? So let's look at some more pictures here. Look at that, folks. If people say that when the astronauts left Earth and went to the moon, Okay, this outer edge here is 36,000 miles. A funny thing that happened on the way to the moon footage, excuse me, is talking about when the astronauts were 110,000 miles out, and the moon is 237,000 miles away, according to the NASA numbers. So, of course, the astronauts went through both of these belts, according to what they report, what they allege. So when people say, no, we didn't even have to go through the inner belts because of trajectory, well, does that mean they took off this way and went straight over Great Lakes and came out and hung a sharp right and zigzagged through space and avoided all the and then orbited around that? I mean, baloney. What does this mean on a flat Earth model? I think all you would do is take that and flip it up just like half a bagel, and maybe instead of one dome, we've got a point where it actually comes down and touches over the center point, North Pole, and over the climatic zone, say between the 50th parallels and the equator, you're going to have a dome on either side of the plane going around you like a half a bagel or half a donut cut in half, like the halves you would put in a toaster. So it's really not that hard to convert this to the flat Earth model. It works the same way. But anyway, so people who say that astronauts did not have to go through the Van Allen belts because of their trajectory, please prove it to me and explain it, okay? That's it. I'm Alex Aquarius. This is a Plain Mundane Show. Please hit like and subscribe. And over and out until I post another video. Ciao.